Let's have a look at some methods for tabulating and cross-tabulating data in Stata. So what we're looking at here is some data from the Scottish Crime and Justice Survey. And I've selected a variable that asks about fear of crime. Up here we've got how worried. The question is, how worried are you about having your home broken into? It's an ordinal response, and the respondents have 4 options. Not at all, not very, fairly, and very. So we can read the distribution here in the percentage column, the frequencies if you wish. And what we're looking at down here then is a cross-tabulation, which is where we introduce a second variable, an independent variable, to try and explain variation in fear of crime. So in these cases where we have bivariate tables, we refer to these as cross-tabulations. You might also see them referred to as contingency tables or pivot tables, depending on what you're reading. And what this allows us to do then is to look at the spread or the distribution of categories or levels of worry within each of these categories of the independent variable. In this case, it's urban-rural. So this variable measures whether the respondent lives in an urban area or a rural area. And within this then we're able to see fairly clearly that fear of crime seems to be a little bit higher in urban areas than it is in rural areas. If we look at the percentages marking very worried and fairly worried, we see we've got a higher set of percentages here for urban than we do for rural. And in Stata, we get a couple of pieces of information in these tables. First of all, the orientation of the tables is important, and I'll explain a little bit more about that in a moment. But basically what we want to make sure is that as we're reading across here, as we read our percentages, we make sure that the percentages sum to 100 within categories of the independent variable. This is what we call row percentages. You can change this if you want, and sometimes we do change it to reflect the orientation of a table that might be awkward, where there might be several categories of the independent variable and low variation on the dependent. But the basic rule is that you want your percentages to sum to within categories of the independent variable rather than the dependent. So to sum to 100 this way rather than that way. And again, it's not necessarily that they're always read vertically and horizontally. It depends on the orientation of the variable. Sometimes we might use column percentages if we wanted to change the orientation of the table to accommodate a particularly long independent variable. But I'll explain more about that in a moment. So here we have categories of the independent variable, the row variable, and here we have categories of the dependent variable, the column. So here are the categories of fear of crime, and then the categories of urban-rural. Now we get several pieces of information in the cells. This figure here, 11.58, is the percentage of urban respondents who say they are very worried about crime. This figure down here, 20.85, is the percentage of rural respondents who say they are not at all worried about crime. And this allows us then to compare across the two categories of the independent variable. So to look at levels of high worry between urban-rural respondents and low levels of worry between urban-rural. The column percentages then are the percentage of all respondents who are not very worried about having their homes broken into. So if we were to ignore the independent variable, go back to the original table grouping, and you'll see here that these match the original grouping where we haven't introduced any variable whatsoever. We've got 47.45 here, and we've got 47.45 on the bottom. These are the results or the percentages for the whole sample. As we read then from left to right, we see that we have 1,650 respondents in the urban category, 542 in the rural category, 2,192 overall in the entire sample. And because we're looking at the percentages within each of these categories, these percentages should sum to 100. So the general rule here is when reporting a contingency table, of course, we need to pay attention to the number of individuals in the cell. We need to be sensitive to the overall sample count, of course. Where this will become an issue later on is if we're dealing with very large tables where the cell count, the number of respondents in any one cell, might fall below 15 or 5. Beyond that, we really do want to make some accommodations for that, maybe by changing the coding of the variable somewhat. So let's take a look and see how we implement this in Stata. The basic command for tabulating a variable is the tab command. This is a shorter form of tabulate, the longer tabulate command. As I mentioned before, a lot of these basic Stata commands can be truncated or shortened, and Stata will still recognize it. So I'm going to highlight that command and execute it. And we see here that we have a variable that measures, that records the party the respondent voted for in the last national election, and it simply tells us the percentage of respondents that voted for each particular party. There is another command that's available to do this. You will have to run this little piece of code first of all to install it, but it's quite a useful command. It's the FRE command, and you can install that by typing ssc install free. It's already installed on mine, so I won't run it again. And when you do that, you will have access to the FRE command. And what that does is, it's similar to the last one. You just get a couple of different pieces of information in a single table. We can recall this information in different ways using other commands, but I quite like this one because it keeps everything on the same table. So not only now do we get the same percentages as before, we also get a recording of any missing categories that are active or that are currently being used as decode categories. And we also get the numeric label associated with each of the numeric value associated with each of these different categories. So category 1 is coded anti-austerity alliance, number 2 Fianna Fáil, number 3 Fine Gael, and so on. Remember that whenever we deal with survey form data with questions like this, what we always do in the data entry stage is we translate these text categories into numbers using codes. So later on, if we want to manipulate the data, if we wanted to just look at, say, all Fianna Fáil voters or Fine Gael voters, we will need to know what the numeric code is attached to that. So the FRE command is a useful one to get used to because it gives us all that information in one command. From here, we can introduce a second variable to produce a cross tabulation. Now, the orientation of the variables in the command is important. So I'll run it here with the variables in this order, and you can see what we get. So here we have in the rows, so the row variable is political party, and the column variable is gender. And you'll see here, all we have if we run the command like this is the cell counts, the number of respondents. Here we have the number of male respondents who voted anti-austerity alliance. Here we have the number of female respondents who voted Fine Gael. This is not as useful, of course, because what we need are the percentages. So we can get percentages returned by adding an extension to the command which says COL, or short for column, and this will ask Stata to give us column percentages. So if we run that piece of code, we get a table with, now we have the cell counts as before. You see here we've got 5 and 4, same as before, 5 and 4, and now underneath the cell counts we've got the percentages. So 28.95% of males voted for Fine Gael, 33.19% of males voted for, 28.95 voted Fianna Fáil, 33.19 voted Fine Gael, and so on. 8.13% of females voted for Sinn Féin. And we see here that this table follows the rule where the percentages sum to within categories of the independent variable. Remember, why is it independent? Because we're hypothesizing that party vote, or that the party somebody votes for, is dependent on the respondent's gender. So gender in this case is the independent variable, and party is the dependent variable. We can change the orientation of these tables with a few small amendments. So I'll show you what I mean by that, and this should also illustrate to you why sometimes we might want to change the orientation of the tables if a variable has a particularly large number of categories. So if I start with gender first, and then I put in the party variable, you'll see here it'll give me a table that's a little bit wide, and now it's also giving me, because I've asked it to give me column percentages, instead of showing me here that 0.73% of males voted anti-austerity alliance, now it's showing me that 55.56% of anti-austerity alliance voters were male, and 44.44% of its voters were female. 52% of Fianna Fáil voters were female, 47.26% were male. And this is, it's still legible, of course, it still makes sense, but it's not what we necessarily want to report given the way that we've set up this hypothesis. We're looking for the distribution of parties within categories of gender. So what we can do there to modify that is to simply change the orientation of the percentages. If I switch that to row and run it again, now you'll see that we have the percentages like we had before. The table just has a different orientation. And you see, whereas in the first one, I could see here we have 28.95% of males voting Fianna Fáil, 30.44% of females. We now have the same information here again in this table. 28.95% of males, 30.44% of females. And again, it satisfies the rule that our percentages sum to within categories, sum to 100 within categories of the independent variable. Same as they do in this one. So the general rule for this is when the independent variable is in the row, we ask for row percentages. We use this extension row. When the independent variable is in the column, we ask for column percentages. So the easy check for this is to check your logic on it to see where is the independent variable, and that will tell you generally for most cases where or how the percentages should be specified. But again, if you go back to these examples, you can refer back to the do files for week 3 where the rule is restated and an example is given. You'll be able to work through a couple of these to get a handle on it. We can also add another extension to the command, which is the no fric, or the no frequency. And what that will do is it will suppress the frequencies for us if we just want to get something to report the percentages. This is not always useful because, again, like I said, we want to keep an eye on the cell counts to make sure. You see here in the Socialist Party, we've only got only 4 in the sample voted for the Socialist Party, so we can't be terribly sure about the gender distribution between these parties with low cell count. And there are issues later on. We'll see if we want to infer on this or to generalize out from this table. We might be invoking too great a risk by relying on a table with small cell counts. But we'll get into the technicalities of how and why that arises later on and what we can do about it. So that is a basic primer on contingency tables in Stata.